let's move to the last talk of today, of this session, sorry. And the paper is named Large Language Models as Evaluators for Recommendation Explanations. And this one is a reproducibility paper. Yes, you can use this one.
Hi everyone, and I'm Xiaoyu Zhang from Tsinghua University, and I'm delighted to share my reproducibility work titled Large Language Models as Evaluators for Recommendation Explanations. Okay. An ideal recommendation explanations concerns diverse goals, but to conduct an efficient and effective evaluations of these aspects is not that simple. For example, if we want to verify an enhancement in persuasiveness or user satisfaction, commonly used reference-based scores like Roche and Blues may not be good enough, since they mainly rely on text similarities. Thus, human labels like third-party annotations and real user feedback are required, but these labels are expensive and has their own drawbacks. Actually, it's a problem I met with when doing my work, so it comes to me that can be solutions for evaluating the quality of recommendation explanations, since it is lower cost than human labeling and has almost no dataset limitations. Also, recent year has witnessed that reached promising results on assessing many NLG tasks. However, these experiences cannot be migrated to the evaluation of explainable recommendations without verification. This is mainly because the task is relevant to real human feelings and aiming at a group of diverse goals. So our work aims to examine the feasibility of utilizing evaluation recommendation explanations, and we detailedly studied 3 sub-research questions. Okay. So here's a main data structure of our work. We have real user feedback and we mainly conduct meta-evaluations based on different annotations, including real user feedback, third-party annotations, reference-based scores, and LLM evaluations, in which real user feedback and self-explanation text for calculating the Blue and Roche scores are from existing work, and we directly use the dataset, and additionally collect third-party annotations and annotations. The real user feedback contains around 10,000 5-level labels from 39 persons. Each were presented with 8 personalized recommended form, and users are asked to give a 5-level ratings on 4 aspects towards 8 different explanation texts. The third-party annotations follow the similar settings, but we employed 2 annotators to giving the labels. And for the LLM annotations, we primarily utilize in-context learning to make LLM follow human instructions. Having collected all those data, we conduct meta-evaluation, which is evaluating the quality of these collected evaluation labels. We have a premise that we think the real user is the ground truth evaluators. Thus, we can use correlation coefficients for assessing evaluation accuracies. Higher coefficients with real user feedback suggest a higher evaluation accuracy. In addition, we propose that when conducting meta-evaluation, the strategy can be divided into 3 levels. For dataset level, correlation calculates the correlation of all scores. And for user level, it calculates the correlation within the data of each user. And for pair level, the calculation is happened within the data of each user and item pair. So why we need this multi-level discussion? We can see from the results, here we here we highlight the results of the blue 4 score on these 3 levels, and we can find that blue 4 score demonstrate a negative correlation at dataset level. This is mainly because that some reference tags may contain more commonly used token combinations than others, potentially inflating the scores and introducing a bias that is unrelated with user perceptions. Thus, an unsatisfactory dataset level correlations didn't definitely mean unsatisfactory correlations on other levels. So the appropriate level of correlations to reference should depend on the specific test settings. Here we show our findings on the research questions. In the table, we test the correlation of different evaluation methods on 4 aspects and 3 levels in the table. And the single aspect prompt settings means that the LM is required to give the evaluation on only one aspect in interactions. And on the multiple aspect prompt means the LM are required to answer the label of the old aspect in one interactions. We can find that LMs can match or exceed traditional accuracies at lower cost. Also, evaluation accuracies vary by aspect, and multiple aspect results are more stable and require fewer total tokens. We can also see that evaluators show different trends across meta-evaluation levels. And for the research question tools, we gave human labels as examples to the LM. The green bar suggests a non-personalized human rating example is given to the LM in the prompt, and the yellow bar shows that personalized examples are given. We can find that both personalized and non-personalized examples benefit the evaluation accuracy of GPT-4, but non-personalized one-shot learning doesn't work well on Tsinghua dataset. Lastly, we discussed can LM collaborate with each other to enhance evaluations. In the figure, the x-axis shows the number of the exampled models, and the y-axis shows the evaluation accuracy. So we find that exampling of multiple LMs improves evaluation accuracy and stability, and the upper bound of evaluation accuracy decreases as it rises on accuracy aspects. As a primary investigation into the problem, our work is still limited in some aspect. Firstly, the method is relatively simple, and the experiments were mainly conducted under limited settings. We think that exploring more methods in different scenarios is worthwhile for future research. And lastly, if we want to let's go a step further to reconsider the evaluation of explanations. As we have said before, an ideal recommendation explanations concerns diverse goals and aspects, and within this aspect, some are more objective and some are more subjective. For example, there's readability versus persuasiveness. Thus, we think that when using LLM to evaluate the quality of explanations, it requires not only of the ability of LLM as evaluators, but also a problem of whether LLM can simulate real human subjects. So our main takeaways are, firstly, LLM can serve as a standardized and cost-effective solutions for evaluating recommendation explanations. Also, we propose that a multiple-level analysis is essential when selecting the appropriate evaluators. Okay, thanks for listening. And here's, if you want to learn more, you can pay attention to our open source code and the archive version of our paper. And thanks for your listening. That's it.
Okay. Thank you so much for your talk. And yes, there is a question probably from the platea, please. Probably it's not working. It's turned off. In the meanwhile, I will read a question from Slido. There are two similar questions, so I will try to sum up them. And the question is, for LLMs as evaluators, how to deal with the bias that may exist? And also, how to deal with the uncertainty that you have in LLMs? Do you have any suggestion about this?
Firstly, about the bias introduced when using an as evaluation, I think the problem really exists. But I think there will be the similar problem if you're using a third-party annotators. For example, I think it's like using third-party labels is an often used method in the community, and like if these annotators have like they will also be biased in their maybe genders or their ages. So yes, I think this problem exists, but maybe we can have some algorithm to for the LLMs, but I think the bias may be more difficult to solve when you're using like third-party annotators, or the procedure may be not standardized enough. And also for the uncertainty. And firstly, in our experiments, we set all the temperatures to 0 or as low as possible to mainly reduce reproducibilities. And like in our opinion, like I think there can be many advancements in the method because, for example, we can. In our method, we can see that the prompt is relatively simple, but actually, like we can give some like more detailed user profile to the or use some agent-like method to to make them more simulate real humans. And I don't know because I think that certainly sometimes we want to increase the uncertainty, and sometimes we want to decrease the uncertainty. But I think for both way we can find a method for the both trends. Yeah.
Okay, thank you. Just the last question. Sorry, but we are a bit late. So yes, please.
Thank you for the talk. I was wondering. The metrics you listed were accuracy, user satisfaction, transparency, and persuasion. And so in light of, I guess, this morning's keynote talk, do you have any thoughts on the correct choice of evaluation metrics, particularly like this persuasion metric that you have?
You mean for the specific metric for persuasiveness? I don't know whether I understand your questions, but actually I was thinking about maybe for persuasiveness. I think actually in my experiences, and I find that persuasiveness might be a relatively easy aspect for LLMs, especially compared with user satisfaction, which might be more personalized. But if we are talking about what traditional metrics can work well on persuasiveness, actually I cannot think and name one at this moment. Yeah, I think that. But I know there are many model-based metrics, but there still need human labels to train and to utilize. So I don't know whether I answered the questions.
Okay, so thank you so much. So let's thank the speaker again.